Good morning, my friends. Welcome to my channel, Belagali's classes. Belagali's classes. My friends started with a calculus. We have done two classes, means two videos. Almost the first video, the basics, everything about the function, what you mean by variable, what is constant, types of functions, everything just I explained in the first video. Second video, just value of the function, limit of the function, those concepts I made it clear. Then I started with a continuity of a function in the previous video. Yes, my friends, connected with continuity of a function, whose graph is without break, it must be a continuous curve. Yes, a function fx is said to be continuous at a point x equal to a if the limit of fx as x tends to a and f of a, what is f of a? Value of the function at x equal to a exist finitely and they must be equal. Limit of fx as x tends to a must be equal to value of the function. Yes, my friends. If the limit doesn't equal to value, in that case, opposite function is said to be discontinuous, non-continuous, not continuous. All these are the things we use. Yes, my friends. Sometimes they will ask what? Define continuity of a function in the interval. Interval means what? It contains so many points in the interval. Everything I made it clear. Interval, closed interval, open interval, everything it is made clear earlier to this. Yes, my friends, it is an interval I, may be open, may be closed. Then a function is said to be continuous in interval I if it is continuous at each and every point of the interval. My friends. Remember, it is about the interval. But one more thing, yes. That another thing is about the limit, my friends. That also I made it clear, just a reminder which we need here. Yes, friends. Once again, about this. What is that? Limit of a function as x tends to a exist only when, or if and only when LHL means left hand limit of the function must be equal to right hand limit of the function. That is, left hand limit, it is limit of fx as x tends to left of a means values of x less than a, denoted by writing a minus. Right hand, what is it? It is limit of fx as x tends to a plus. A plus means what? Values of x greater than a, values of x less than a. If the limit of fx as x tends to a through left, my friends, still it is here. Through left, this is x equal to a. It is left of a, this is right of a. This plays a very important role, my friends. So I think the examples. X is a. Values of x less than a, we say x tends to a through left, denoted by x tends to a minus. A minus means these are the values less than a. This minus denotes something less, little less. Explained everything. My friends, in this case, LHL, limit of fx as x tends to a. If the limit of fx as x tends to a through left or by taking the values less than a exist, that limit is called as left hand limit. Therefore, left hand limit equal to limit of fx as x tends to a minus. What about this side here? What is this, my friends? My friends, This is left of A, this is right of A. Right of A means what? Values of x greater than A. Values of x greater than A. Written symbolically, what is it? Limit as x tends to A plus. A plus means greater. A minus means smaller. Equal to means exactly same. My friends, A plus means not like here 100, 200. These are the values of x which are very near to A. It comes like this, x tends to A through right from this side, my friends, this side. Now these are the values little greater, A plus H, A plus 2H, A plus 3H, like that. What about that H? This H is a very, very small positive number. Very, very small positive number. In this case, my friends, nearer to A means what? A minus H, A minus 2H, A minus 3H, like that. All these are the values approaching what? The value A. This is less symbol. If the limit exists, name. It is equal. What is its name? If it exists, value of the function at x equal to A, it is value. Symbol f of A. This side, my friends, greater than A. Symbol. Limit of fx as x tends to A plus. If this limit exists, what is its name? Right hand limit, written in brief, RHL. So my friend, RHL is this, LHL is this, and my friends, this limit of a function fx as x tends to A exists only when both are equal, my friends. LHL equal to RHL. Otherwise, if LHL is not equal to RHL, limit does not exist, or if any one among the two doesn't exist, the limit of the function does not exist. Yes, my friends, for this limit, very important. What is that? LHL, RHL. A minus, A plus. A minus, A plus. The next even I have explained, my friends, how to find left hand limit and right hand limit. To find left hand limit, replace. To find left hand limit, replace x by A minus H. A minus H. And take the limit as x tends to 0. Limit as x tends to 0. And to find RHL, for RHL, replace x by point plus h, and take the limit as x tends to 0. Therefore, my friends, LHL equal to this equal to what? This is limit as of x as x tends to 0. Replace your x by A minus h, and take the limit as h tends to 0. This must be equal to, in finding RHL, replace x by A plus h and take the limit as h tends to 0. Therefore, my friend, LHL, limit of fx as x tends to A minus. Next step, replace x by A minus h, point minus h. If x tends to 2 minus h. If x tends to 0 minus h, like that, my friends. This is for the LHL, this is for the RHL. For the limit, both must be equal. In case all the three are equal here, my friends. In case, therefore, limit of fx as x tends to A. This limit exists if LHL equal to RHL. Therefore, this definition is extended like this. What is that? A function fx is said to be continuous at x equal to A. If all the three, my friends, value LHL, RHL, all the three must exist finitely and they must be equal. If all the three are equal, in that case the function is said to be continuous at x equal to A, my friends. Otherwise, the function is said to be discontinuous at that point. Discontinuous, not continuous, non-continuous. All these are the words to use for the discontinuous. Otherwise means what? I told you. Anyone not equal, anyone doesn't exist. In that case, the function is said to be discontinuous. I gave the example of this, my friend. fx equal to x square minus 4 upon x minus 2. In this case, the value of the function fx fails to exist. Value of the function fx at x equal to 2 fails to exist. I tell, if you put x equal to 2, 4 minus 4, 2 minus 2, which is a undefined, indeterminate form. Therefore, value doesn't exist, but limit exists. Everything I made it clear. Now I have to do examples based on this, my friends. Examples of this will come under what? 4-mark question. 4 mark, that is part E. Part E. Okay, one example. Yes, my friends. Just I explained the things which we have done in the previous two videos. Now, coming to examples, I do some 1 or 2 examples, simple. Yes, my friends. I keep it for 1 or 2 examples, my friends. 1 or 2 examples. Yes. Yes, my friends. Examples. Prove that the function fx equal to 5x minus 3. 5x minus 3 is continuous at x equal to, yes, my friend, minus 3 at x equal to minus 3. For the continuity, my friends, when to use LHL, RHL, and when to use only limit. This is another definition is what? The function is said to be continuous at x equal to a. Yes, if, tell my friend, limit of fx as x tends to a equals value of the function. Then this exists only when LHL equal to RHL. This implies, my friends, this. It is a further extension to, my friends, either this or this. Then when to use this, value is same. When to use this and when to use this. My friends, if fx is defined separately for what? X less than the point, x greater than the point. If it is not given separate for lower values for higher values, in that case you can, my friends, use what? Directly you can find only limit instead of LHL, RHL. Yes, my friends. See here. I directly write value of fx at x equal to minus 3. This we write it as what? F of minus 3. Substitute here. This, my friends, 5 into minus 3, what is it? It is minus 15 minus 3 means it is minus 18, my friends. This is value. So, f of minus 3 is minus 18. This is value. Next, you have to find limit. Limit of fx as x tends to minus 3. What is fx? Limit as x tends to minus 3. Fx is 5x minus 3. 5x minus 3. Yes, my friend. What is this? You have to put the value of limiting value of x. my friends, I explained actual value, limiting value. Now, if you put x equal to direct equal to, it is a functional value. Value of the function at x equal to minus 3, only 1. What is this limit? What is this limit? Even though it is same, my friends, it is minus 15 minus 3, which is minus 18. Yes, my friend, minus 18. This is exact value of f. This is the limiting value of f. Limiting value means, my friends, that value never be minus 18. It is a value which is near to minus 18. It may be little more, little less than minus 18, but it never be minus 18. But in this case, exactly minus 18. This is functional value, this is limiting value. In this case, what? Both are equal. Both are equal. Therefore, limit of fx as it extends to minus 3 equal to f of minus 3 value. This tells when both are equal, in that case, fx is continuous at x equal to minus 3. Continuous at x equal to minus 3. Yes, my friends. In this case, even though if you go for what? LHL, RHL, you will be getting the same thing. You will be getting the minus 18. Yes, my friends. This is one example, very simple example. Sometimes any examiner for your other than the board exam, if they conduct any exams with your respective colleges, they may give, my friends. They may give, my friends. Yes, yes, my friends. This is one example. One example. If you wanted, just to try one example, just instead of only one, you may try this at home. Show that the function, prove that the function fx equal to 2x square minus 1 is continuous at x equal to 3. Continuous at x equal to 3. Now, my friends, write it yourselves. See, f of 3, 3 square, 9, 18, minus 1, 17. Again, limiting value, limit of fx, limit of this, same you have to put. You get 17, 17, both are equal. In that case, what we are saying, the function is continuous at x equal to 3. Yes, my friends. These are some very simple examples. Simple examples. By making use of this man, I go or do what? One very important property, or you can say one very important example that we use while doing especially examples on mean value theorems. They we use. Yes, you know these things, man. What? Fx and gx are two continuous functions. Fx and gx are two continuous functions. Both are continuous at x equal to a. If fx and gx are two continuous functions at x equal to a, then their sum fx plus gx, their difference fx minus gx, their product fx into gx, and their division, what is it? It is fx upon gx, where ga is not equal to 0. The denominator is not equal to 0. Yes, my friends, what is it? If fx and gx are two continuous functions at x equal to a, then their sum, difference, product, division, continuous. Continuous at x equal to a. You mean sum of continuous functions is continuous, difference of continuous functions is continuous, product of two continuous functions is continuous. Even division is continuous. Division is continuous. Yes, my friends. Even any constant function is continuous. Constant function. Any constant function is continuous for all x. Continuous for all x, my friends. Why tell? If you take any constant k here, if your function is constant k, tell. What is f of k at x equal to a, my friends? Same it is. At x equal to a, tell. What is the value of k? What is the limit k? They are equal, then the function is continuous. Therefore, my friends, even what? Even what? A constant function is a continuous function. Constant. Yes, my friends. I go with what? Just one useful property. Useful property. We are going to use it. Yes, first I prove that the function x to the power n, where n is a natural number, n is a natural number, n belongs to n, is continuous at x equal to a. Yes, my friend. What is value? Value. Value is f of x at x equal to a. Just you are putting what? E to the power n. And that x is everything not equal to 0. Yes. Then comes limit. Limit of fx as x tends to a. What is it? Limit of x to the power n as x tends to a is what? A to the power n. From this, what is clear, my friends? From this, it is clear. Limit equal to value. Limit of fx as x tends to a equal to value means what? F of a. This gives fx equal to x to the power n is continuous. Is continuous at x equal to a, my friends. Similarly, if you put different values here, tell x is continuous, x square is continuous, x cube is continuous, x to the power 4 is continuous, x to the power 100 is continuous. Yes, my friends, all these are continuous functions. Similarly, we can say, x to the power n minus 1, x to the power n minus 2, all these are continuous, or continuous at x equal to a. Implies sum of all these continuous functions, sum of all these continuous functions, continuous functions is continuous. At x equal to a. What next, my friends? What is that x equal to a? Is an arbitrary point, arbitrary constant. That x equal to a is an arbitrary constant. Even you may choose instead of a, b, you may choose k, you may choose 10, you may choose 15 like that. In that case, you can say that sum of all these functions means it is a polynomial function. Therefore, a polynomial function like this, an into x to the power n plus an minus 1 into x to the power n minus 1 plus dash dash, it is what? Is a continuous function. Is a continuous function. It is for what? All x, my friends. Continuous function for all x belongs to R. For all x belongs to real numbers. Now at the beginning only, my friends, as we wanted, a polynomial function is always a continuous function. It is a very, very useful result, especially in proving or in doing the examples on mean value theorems. My friends, we use this property. Just we identify it as what? polynomial function. These are what? Polynomial functions of a different degree. It is a polynomial function of what? Degree n. What is this? It is x square plus 2x plus 1. It is a polynomial function of degree 2, quadratic. Even you can say ax plus b, 2x plus 3, only x like this. All these are what? My friends, all these are the polynomials. Hence, by this statement, every polynomial function is a continuous function. While doing mean value theorems examples, we use many. If it is a polynomial with this result, it is a continuous function, continuous function, continuous function of what? All x belongs to R. This is one property, or you can say one useful result, and useful result that you must underline. Yes, my friends, this is one. This is one. Next, I do your examples, my friends. Examples. Yes. Next example is. Next example is. Next example. Yes, my friends. Examine the continuity of the following functions. Examine the continuity examine the continuity of the following functions following functions. Yes, my friends. Yes, my friend, this is the property. What is that? Sum of two continuous, difference of two continuous, product of two, division of two. Continuous functions are what? Continuous functions again. Then any constant function, any constant is a continuous function. Any constant is a continuous function. Yes, my friends. I need this for the little time. Yes, I think. Yes. Examine the continuity of the following functions. 1. Fx equal to x minus 5. X minus 5. Directly you can write in one line. What is that? X minus 5 is a polynomial function. Every polynomial function is what? Continuous. So x minus 5 is continuous. Finished. One line. Otherwise, you can write what? First value. What is value? F of 5. What is f of 5? 5 minus 5. What is 5 minus 5? 0. Therefore, value is 0. What next? Limit of fx as x tends to 5 equal to. Put the value of fx. What is fx? X minus 5 as x tends to 5. Put the limiting value. 5 minus 5 is 3. My friends, you know the difference between f of 5 and limit of fx as x tends to 5. This 0 is a functional value, exact value, only 1. What about this 0? Limiting value. Limiting value means it is not 0. Then what is it? It is a value which is very near to 0. Very near to 0 means, in this case, you can. These are the values which are very near to 0. In that case, limiting value means it is very near to 0. What is this? Exactly 0. But limiting value is equal to functional value. Limiting value equal to functional value. If it is so, by definition, fx is continuous. Fx is continuous at x equal to 5. Yes, my friend, this is one. Next I take the same It is in the numerator, the same is in the denominator, my friends. The same is in the denominator. See there. What is it? What is it? Yes. This is 1 upon x minus 5. It is in the denominator. Value f of 5. What is f of 5, my friend? It is 1 upon 5 minus 5. What is it? 1 by 0. This, my friends, very danger light. What is it? Division by 0 not allowed. Division by 0 not allowed. If it comes, what is it? It is undefined. What is it? Friends, division by 0 not allowed. If it comes, undefined. That's all. It is not defined. Not defined. Yes, my friend. Which is not defined. Which is not defined. From this tell, my friends, what is clear? Fx is defined except what? This gives Fx is defined. Fx is defined for all x except 5. For all x except 5. Or you can write for all x not equal to 5. Except this. For all x not equal to 5. Yes, my friends. Or next, you are finding the limit. Limit of fx as x tends to 5. In this case, my friends, it is tends to. No question of what? Equality here. Tends to means x is not equal to 5. Yes, my friend. In this case, limit of what? 1 upon x minus 5. X minus 5. As x tends to 5. Yes, my friends. Yes, my friends. Here itself you can tell in one line. What is that one line? As it is not defined, here itself you can say the function is continuous at all except x equal to 5. Otherwise, yes, my friends. My friends, what is this? Limit as x tends to 5. Anyway, it is not equal to 5. The function is continuous. No need to find the limit. So here itself we can say the function is continuous. Fx is continuous for all x except 5 means not equal to 5. This way. Similarly, another function here. Another function fx equal to 1 upon x square minus 25 at x equal to 5. Yes, fx equal to 1 upon x square minus 5 tell at x equal to 5. At x equal to 5. Same thing here. The value does not exist at x equal to 5. What about f of 5, my friend? F of 5 is 1 upon 5 square is 25 minus 25. Yes, my friend. It is 1 by 0, which is undefined. Which is undefined. From this, whatever saying, fx is defined. Fx is defined for all x. For all x except 5. Or we can write there itself not equal to 5. Except 5. This. Other than this, in the remaining it is defined. Then what about the limit? What about the limit? This is limit of fx as x tends to 5. Yes, my friend, this is limit of fx means what is this? It is 1 upon x square. 1 minute. This is x plus 5 upon. Yes, one correction side. This is x square minus 25 upon x minus 5. X minus 5. Even you can take the earlier also. Okay. In this case, it is what? 0 by 0, my friends. This is 5 minus 5. It is 5 minus 5. Here it is 25 minus 25. It becomes what? 0 by 0, which is undefined. Yes, fx is defined for all x except at x equal to 5. Even the same thing is a denominator, same, it becomes 0 by 0. Now it is limit of fx as x tends to 5. Yes, my friend. This is x square minus 25 upon x minus 5. Limit as x tends to 5. Limit as x tends to 5 means x is x tends to 5. X tends to 5 implies what? X never be 0. When x never be 0, x minus 5 is not equal to 0. When x minus 5 is not equal to 0, you can write the factors and cancel. Limit as x tends to 5. Write the factors of this. X minus 5 into x plus 5. Yes. Denominator is what, my friend? X minus 5. Yes, tell. Can you cancel it? Yes, 5. X minus 5 is not equal to 0. When it is not equal to 0, you can cancel it. Remaining, you are left with limit as x tends to 5 of what? X plus 5, which is 5 plus 5. What is 5 plus 5? 10, my friends. So, in this case, the limit exists, but value does not exist at x equal to 5. So, this function, x square minus 25 upon x minus 5 is continuous for all x except x is equal to 5. Means for x not equal to 5. It is continuous for all x not equal to 5. Yes, my friends. So from this it is clear. So this is clear. What? Fx is continuous. It is clear. Fx is continuous. Fx is continuous. Continuous for all x except 5. For all x except 5. Yes, my friends. These are two examples there in your book in CRT. Okay. 1 upon x minus 5, x square minus 25 upon x minus 5. These are the two examples where the function is continuous except x equal to 5. Why? At x equal to 5, the given function is undefined. You get what? 1 by 0, otherwise 0 by 0. Both are undefined. Why? Division by 0, not allowed. Yes, my friends. I take other than this, next example. See. Yes. In this case, examine same fx equal to mod x minus 5. Mod x minus 5. I have done x minus 5, 1 upon x minus 5, x square minus 25 upon x minus 5. The next is about what? Mod function. About the mod function. Yes, my friends. Now you know the definition of this. This is mod x. We define mod x equal to what? Plus x. If x is positive and equal to minus x if x is negative and equal to 0 if x is 0. This is definition of modulus. It is plus x if inside is positive. It is minus x if inside is minus x. Inside is 0. Mod 0 is 0. This is my friend. Mod 0 is 0. Yes. First one. Value of the function fx. Value of f at x equal to 5, that is understood. Value of f at x equal to 5. My friends, we write symbolically f of 5. Put x equal to 5. 5 minus 5. What is it? Mod of 0. I told mod of 0 is 0. So f of 5 is 0. Value f of 5 is 0. Yes, my friends. Now, by the definition you can see here. By the definition you can say, what is it? Plus if x is positive, minus if x is negative. Then, now that mod is defined for both man. When it is what? Greater than x, it is less than x. Yes, my friends. When two values, positive, negative comes in that case, you have to go for what? LHL and RHL. You have to go for LHL and RHL. Yes, my friend. I write first LHL. I write LHL. See. From this, what is this? Mod of x minus 5. Mod of x minus 5 equal to, it is plus x minus 5. Tell my friend. If x is greater than 5. Greater than 5 means what? It is 5.5. 5.5 minus 5 means 0.5. What is 0.5? Positive. If it is positive, outside is positive. If it is positive, outside is positive, my friend. Means x is greater than 5. And equal minus x minus 5, whatever it is. That is, if x is less than 5. Less than 5 means, my friend, it is 4.5. X is 4.5 minus 5 means it is minus 0.5. Minus 0.5 is a negative number. If the inside is negative, outside is negative. See here. If x is negative, outside is negative. If x is positive, outside is positive. So, when x is less than 5, it becomes negative. When it is negative, outside is negative. When x is greater than 5, 5.5 plus, in that case it is plus. I hope my friends understood. We use this for RHL, this for LHL. Yes, my friend, RHL. This is limit of fx as x tends to 5 plus. Yes, my friend. It is limit as x tends to 5 plus. When it is 5 plus, x greater than 5 plus, what is your fx? Plus x minus 5. This is plus x minus 5 means positive. Then you know the method. Replace your x by 5 plus h and take the limit as h tends to 0. Method of finding RHL, LHL. Replace x by point plus h. Replace x by point plus h. This is as usual minus and take the limit as h tends to 0. Yes, plus minus cancels. What is this? It is limit as of h as h tends to 0. What is this, my friend? RHL is 0. Therefore, RHL is 0. RHL is 0. Next is LHL. What is it? It is limit of fx as x tends to 5 minus. Yes, my friend. Now this is limit as it extends to 5 minus 5 minus. 5 minus means what? X is less than 5. When x is less than 5, tell my friends, what is your fx? This is what? Fx. Fx is what? Minus x minus 5. This is minus x minus 5. Same, next. Replace your x. Limit as x tends to 0. 0. Write it as it is. Minus. What is inside? It is 5 minus h minus 5. Yes, my friend, you have to replace this x by minus means minus. 5 minus h, this minus 5. Yes, see. This is limit as x tends to 0. This plus 5 cancels with minus 5. Minus with minus is plus h. Limit as h tends to 0 means what is this, my friend? 0. Therefore, even LHL is 0. LHL is 0. What is your observation? Value is 0, my friend. RHL is 0. LHL is 0. All the three are equal. Therefore, value equal to f of 5 equal to LHL equal to RHL. From this, you can say what? Function is continuous. Function is continuous at x equal to 5. Continuous at x equal to 5. Hope, my friends, clear. It is mod x minus 5. Value. This is given the definition of what? Mod x there. Mod 0 is 0. Then we can define it by making use of the definition. What is the definition? Fx equal to mod. This mod is positive when x is greater than 5. This mod is what? Negative. If inside is negative, that is x is less than 5. RHL positive. Fx is this answer. LHL Fx minus. Minus means what? Negative. When it is negative means less than 5. What is this? Minus x minus 5. Minus means what? Value of x is less than 5. This same simplification 0. In all the three cases they are same, which is 0 itself. For all the three it is equal to what? 0. Therefore, function which is mod is continuous at x equal to 5. Continuous at x equal to 5. Yes, my friends. Next one. Next one. C. Discuss the continuity of the function. Discuss the continuity of the function. Fx equal to, or examine, discuss, everything same. Discuss the continuity of the function. My friends, Fx equal to, it is mod x upon x, mod x upon x. This is defined when x is not equal to 0 and it is 0 when x is 0, means f of 0 is 0. F of 0 is 0. Yes, my friends. Yes, my friends. It is mod x upon x when x is not equal to 0. 0 when x equal to 0. You must discuss its continuity at x equal to 0. Continuity at x equal to 0. At x equal to 0. Yes, my friends. Yes, my friends. First, value of fx at x equal to 0. Fx at x equal to 0, which is f of 0. See, my friend, at x equal to 0, it is given as 0, directly given. Next, my friends, x is not equal to 0. My friend, this is your 0. When x is not equal to 0 means value is greater than x and value is less than x. Then there exist two cases. Not equal to 0 means value is greater than x, value is less than x. Greater than x is for what? RHL. Less than means for LHL. What is this for? Value. Value is already told. This is what? Value. Value is given, it is 0. Then you go for what? RHL, LHL. This is the definition. Here it is. If you wanted, I write it here. Mod x equal to plus x. Values greater than 0 equal to minus x if x is less than 0. Means in both cases what? X is not equal to 0. Either greater, otherwise smaller, but not equal to 0. Yes, my friend. First RHL. This is limit as x tends to 0. Fx. X tends to 0 plus. RHL means value is greater than 0. Fx. Fx equal to. When x is not equal to 0, plus means what? It is more than 0, not equal to 0. When x is not equal to 0, what is your fx? Mod x upon x. This is mod x upon x. As x tends to 0 plus, my friend. 0 plus. Yes. Even you can use directly this. Yeah. What is this? This is equal to limit as h tends to 0. It is mod of 0 plus h. Denominator is what? 0 plus h. What is this? It is limit mod of h. Down is h as h tends to 0. What is mod of h? Is h itself. Denominator is h. My friend, h cancels with h gives 1. Therefore, RHL is plus 1. RHL is plus 1. Yes, my friend. RHL 0 plus. 0 plus means here itself you can write what? Plus x. You can write plus x. Replace 0 plus h upon 0 plus h. H by h is 1. Next is LHL. This is limit of fx as x tends to 0 minus. Yes, my friend. And this is not equal to 0. Not equal to 0 means what is your fx? Mod x upon x. This is mod x upon x as x tends to 0 minus. Yes, what is this? It is limit as h tends to 0. Mod 0 minus h upon 0 minus h. What is this? It is mod of minus h. Down is minus h. See, my friend, negative. It is again a negative means what is it? Negative means it is minus x. Minus h with minus h is plus h, or mod of any number is plus itself. Mod of any number is plus itself. Minus h cancellation minus 1. Therefore, LHL is minus 1, my friends. LHL is minus 1. But from this, what is clear? LHL is not equal to RHL because it is plus 1, it is minus 1. Therefore, LHL is not equal to RHL. And even it is not equal to what? Value here? 0. And even it is not equal to value. Therefore, function is discontinuous. Fx is discontinuous. Discontinuous at x equal to 0. at x equal to 0. Even my friends, you can conclude here itself. I tell what is RHL is plus 1. What is your value? Value is 0. Therefore, value is not equal to RHL. Value is not equal to RHL. You may conclude here itself 5. For the continuity, all the three must be equal. Value equal to LHL equal to RHL. If any one is not equal, in that case, what? The function is discontinuous. Now, by making use of this, my friends, no need to calculate what LHL if the RHL is calculated in the first. Now, if LHL is calculated in the first, it is not necessary 5. Value is 0 and what? It is not equal to either RHL, otherwise LHL. By that, we can conclude the given function is discontinuous at x equal to 0. Discontinuous at x equal to 0. Yes, my friends. Yes, my friends. The same example, interchanging x upon mod x, that you do at home. Do at home this function. Yes, my friend. Discuss the continuity fx upon fx equal to x upon mod x when x is not equal to 0. 0, x equal to 0. Instead of 0, sometimes they may give 1 here. If they give 1 here, at that time, you must go for what? All the 3, 5, 10. In this case, value equals, this value is 1. If the value is 1, what about your RHL is 1, my friend. RHL is 1. Value and RHL becomes equal. So you have to go for what? LHL. In this case, you must find all the 3. Then only you can come to know the one value is not equal. You can conclude what? The given function is continuous at x equal to 0. If they give this as 1, even they may give minus 1, anything. 1, minus 1, 0. Other than this also they may give 2, 3 like that. Yes, my friends, this is one of good example. Good example. Yes, my friends, right. My friends, right. Yes, my friend. There is one more example which contains modulus. I do that also. Contains modulus. I do that also. Yes, my friends. Examine the continuity of the function. Continuity of the function fx equal to fx equal to, yes, mod x plus 3, mod x plus 3 if mod x plus 3 if x is less or equal to minus 3. Next man, minus 2x if minus 3 less than minus 3 less than x less than plus 3. Next, 6x plus 2 if x is greater or equal to 3. Greater or equal to 3. Discuss the continuity at 2 points. One is minus 3, another is plus 3. One is minus 3, another is plus 3. Yes, my friends. First, we have to rewrite this by making use of what? Mod x. By making use of mod x. Yes, my friend, we know this. What we know? We know that mod of x equal to plus x if x is greater and minus x if x is smaller. If x is smaller. Yes, my friend, write it. Write it. Yes. Yes. Just we know, otherwise directly we can make use there. Yes, just a reminder I've written. First ma'am, continuity at x equal to minus 3. Continuity at x equal to minus 3. Yes, my friend. Minus 3. First, value of the function. Value of the function, it is x equal to minus 3. Yes, my friend. Equal to minus 3. X equal to minus 3. What is it? Mod x plus 3. This is mod x. X is minus 3 plus 3. X is minus 3 mod. What is this? Mod of minus 3 is plus 3 plus 3, which is 6. Therefore, my friend, I write f of minus 3 is 6. Yes. Next, LHL. Limit fx as x tends to minus 3. Again, minus, I write that minus here, my friend. LHL, you have minus 3, instead of writing minus here, I write that minus here. Both you can use either front or above. Yes, my friend, is limit as x tends to 3 minus 3 minus. What is it? When x is less than minus 3, what is your fx is this? It is mod x plus 3. Same, right? It is limit as h tends to 0. H tends to 0. Replace, what is it? It is point is minus 3 minus h. Minus 3 minus h. This is plus 3. Plus 3. Yes, my friend, what is this? Limit as h tends to 0 of this. Directly you can put h is 0 now, equal to mod of minus 3 minus 0 plus 3 mod of minus 3 plus 3 mod of minus 3 is plus 3. 3 plus 3 is 6. My friend, LHL. LHL is also what? 6. LHL is also 6. Next comes RHL. Yes. Limit as x tends to minus 3, I write plus on the top, fx. It is limit as x tends to minus 3 plus. Yes, my friend. In this case, minus 3 is less than what? X. Minus 3 is less than x. When minus 3 is less than x, what is fx? Minus 2x. Fx is minus 2x. My friends, no confusion here. These are the two values, minus 3. In this case, x is greater than minus 3, or same is minus 3 is less than x. X is greater than this means this is less than x. And what about in this case? Your x is less than minus 3. When x is less than minus 3, your fx is this. When x is less than minus 3, fx is this. X is greater than minus 3, same as minus 3 is less than x. In this case, when minus 3 is less than x, what is your fx? Fx is minus 2x. Fx is minus 2x. Substitute, even directly you can put this value x equal to minus 3. Otherwise, replacing by h, limit as h tends to 0. It is minus 2 into replace by minus 3 plus h. Minus 3 plus h. Put the value of h. Tends to 0. What is it? It is minus 2 into minus 3 plus 0. It is what? Minus 2 into minus 3, which is plus 6. Plus 6. Therefore, even the LHL, RHL, all the three are equal to 6. RHL is a 6, LHL is a 6, even value is 6. Therefore, my friends, all the three are equal. Value equal to LHL, equal to RHL, and all the three are equal to what? 6. Therefore, Fx is continuous. Fx is continuous at x equal to -3, my friends. X is -3. I hope it is understood. Value here. Less means for LHL. For LHL. -3 is less than x means x is greater than -3. Yes. This is for RHL. This is for RHL. In all the three cases, my friends, what is the calculation? All the three are equal and equal to what? Equal to what? 6. Therefore, function is continuous at x equal to -3. Is also one good example. My friends, one more is there, that is at x equal to 3. See, 3 less, equal, greater, all the three. Yes, my friend. At equal to +3, value +3, +3. Equality is this, my friend. Equality is this. What is it? 6. 3 plus 3 plus 2. It is 18 plus 2. 18 plus 2 means f of +3. +3 is 20. This is 20. Yes, my friend. Next is, I make it first. RHL. RHL extends to 3 minus. Extends to 3 minus. Extends to 3 minus. 3 minus means what? X is less than 3. X is less than 3. X is less than 3. X is less than 3 means 2x. Okay. When x is less than 3, it is minus 2x. Yes. Limit as h tends to 0. Yes, my friend. It is minus 2. Replace 3 minus h. 3 minus h. 3 minus h. 3 minus h. Put the value of h at 0. This is minus 2 into. It is 3 minus 0. 3 minus 0. What is this? Minus 2 into plus 3. Minus 2 into plus 3 is minus 6. Therefore, what is RHL? RHL is minus 6. RHL is minus 6. Next is LHL. Next is LHL. Yes, my friend, I write here. LHL. It is RHL means, my friend, plus. This is plus. This is plus. This is plus. Minus 6. Yes, my friend. LHL. Limit as extends to 3 minus there. 3 plus here. Yes. Yes. It is. Limit as extends to 3 minus. My friends, earlier was yes. This is LHL. 3 minus, say 3 minus h. This is minus 6. Next is RHL. 3 plus greater, x is greater than 2 means 6x plus 2. 6x plus 2. Tell, what is this equal to? This is LHL minus 6, RHL 6x plus 2. Limit as h tends to 0. 6 into. Replace your x by 3 plus h. This is plus 2. This is 6 into 3 plus 0 plus 2. What is it? 6 into 2, 3, 18 plus 2 is 20. Yes, my friend. RHL is 20, value is 20, they are equal but not equal to LHL. Therefore, value equal to RHL, both are equal to 20, but not equal to LHL. Not equal to LHL. Therefore, the given function is discontinuous. Given function is discontinuous at x equal to plus 3, my friends. It is continuous at x equal to minus 3, but it is discontinuous at x equal to plus 3. Little confusion here, little confusion. Little confusion, my friends, it is made clear for LHL. LHL, x is less than 3, it's 2x. RHL, x is greater than 3. In that case, fx is 6x plus 2. 6x plus 2 is for RHL, 2x is for what? LHL. LHL is minus 6, RHL is plus 20. Value is plus 20. Value equal to RHL but not equal to LHL. The given function is discontinuous at x equal to 3, my friends. So, I have done some 2-3 examples based on modulus property. Yes, my friends. So, this much is enough today. Now, I do few more examples in the next video. Thank you very much. Thank you very much.